Hi, everyone. Welcome to Anti-Complex Kubernetes. This is the first time we're trying this particular format and this particular model, but I'm really excited to give it a shot. And thank you, everyone, for being here. Of course, I'm gonna, we'll talk about this provocative and exciting idea of anti-complexity pretty soon. But before I do that, I did want to introduce the two people on this call who have used pictures from many decades ago when we were both young and fresh and full of hope instead of the worn out old husks that you see in front of you now.
Isn't that the truth?
Rhys, would you like to introduce yourself?
Absolutely. Yeah, William, thanks so much for having me. So my name's Rhys Oxenham. I run the engineering team here within SUSE's Edge business unit. So yeah, complexity and scalability is what I have to deal with on a day-to-day basis. So very much looking forward to this conversation. Thanks so much for having me.
Absolutely, and thank you for being here. I'm really excited about it as well. And I'm William Morgan. I'm the CEO of Buoyant, which is a startup that's really focused on the service mesh space. We've been around, believe it or not, for almost a decade. And throughout that time, we've been almost as long as Kubernetes has been around. So throughout that time, we've been helping companies around the world face the challenge of Kubernetes, from day 0 to day 10,000. Okay, so I'm going to start with, and kind of the format of this webinar is I'm going to try and make it as interesting as possible, I promise. I'm going to start with something that's a little bit philosophical, and then we're going to get to, the gory details. And that's where Rhys really is going to come in. So we'll be ready to ask him some hard-hitting questions. There is a chat option on the right. There's also like a Q&A section. So, feel free to enter stuff in there and we'll answer that. We do have some dedicated Q&A time at the end of this. But if anything is particularly relevant, we may just answer it in the moment as well. So let's start out. I'm going to start out with this idea of complexity and what does it mean for something to be complex? And anyone who's involved in software is probably a little overly familiar with this idea. Complexity is a thing that we're always trying to avoid. And I think the best way to talk about complexity is actually talk about the opposite, which is simplicity. And the reason why I wanted to frame this this webinar or this whole series about simplicity and complexities, because this is an idea that we have been talking about in Linkerd, since the very beginning. That was kind of like this whole model. And I feel like as Kubernetes has progressed, just talking about simplicity hasn't really been enough. And that kind of spurred this discussion of, okay, well, maybe there's something more than just simplicity. But one of the foundational things, one of the formative ideas in our heads, at the very beginning of this journey was this idea of simplicity versus easiness. And Rich Hickey, who's the creator of Clojure, gave this really eloquent and profound talk at, I think it was at Strange Loop in 2011. You can find this talk online. It's really worth listening to. Really well done talk. Talks about sprints versus marathons and, thinking, like the value of thinking and planning versus just reacting. But the theme here was, okay, we can actually distinguish. We use the words simple and easy, almost as synonyms, but in software they're really different. And something that's easy is something that's near to our capabilities or near to our understanding. It's near to our skill set. It means, hey, we just have to click one button and we're there, right? Whereas simple means single braided. It means you're doing one task, one job, right? And you can kind of contrast that with complex being multi-braided, where things are intertwined. And so the example that he gave, which I really like, is this idea of the knitted castle versus the Lego castle, right? They're both castles, but everything in the knitted castle is intertwined, right? And everything in the Lego castle is decomposable. And so if you are on maintenance duty, you've got a kid maybe who says, hey, I need help, fixing my castle or modifying my castle. You would much rather have, Rhys, I'll ask you, which castle would you rather be on the hook for modifying?
Lego all day long.
Right. Yeah, exactly. Exactly. So that gives us an idea of what does it mean for software to be simple. It's not just you click a button and it goes. It means you've got to be able to pull it apart. You've got to be able to modify it. It needs to be built of components. Those components need to be composable, and kind of the whole Unix philosophy of like we're taking these little pieces and we're doing each of them does one function, and each of them can be combined together to build these greater things. So that's a really profound, I think, idea in computing, and especially in the horrible part of computing, Rhys, that you and I live in, which is really about integration. A lot of what we do all day is we take projects and we jam them together into kind of to build these larger things. And if those projects are built well, then that kind of composability is there, and you get a Lego castle. And if they're built poorly, then you end up with the knitted castle.
Right. And as we're going to explore a little bit later on, when it comes to edge, trying to do that for tens of thousands of different deployments, simplicity and reducing that complexity becomes really, really important.
Yeah, exactly. And the reason, so, we're going to talk about complexity, and then we're going to really focus on scalability. The reason that I really wanted you to be here, Rhys, is because I think you see an extreme example of scalability in your more recent work on edge. Because that's like one, you're on the far end of one of those axes there. Now, the problem that we encounter, whenever we're kind of facing the harsh reality of building Kubernetes-based platforms, is that our platform is actually required to do a lot of things. So we can't just say, oh, the platform does one thing and it does it well. It can't. The platform has to implement all these capabilities, and it has and it has kind of a scaling, a degree of sophistication where today, if you pick an axis security, I've lumped it into these 5 axes. There's probably more you could do here. And certainly when you're in the enterprise environments, there's things like compliance, and automation that, and cost that become more important. But at least in terms of like raw foundational capabilities, I've kind of lumped our platform into these 5 buckets: security, observability, resilience, scalability, DevX, developer experience, right? You want your platform to be able to do all these things. You're required by the business or by your customers, the developers, to do all these things. And they range all the way from, encryption, kind of nowadays table stakes, right? Which is nice to be able to say, down to, micro-segmentation. Still quite hard to achieve, and I won't go through every category here, but there's a spectrum here. And this is kind of the challenge for us as the builders of platforms, which is, of course, we want simplicity, we want composability, we want the Lego castle, not the knitted castle, and yet we are required to provide a whole set of things.
I think there's also a couple of different pieces that I'd want to call out in this slide. It's how do I build that castle in the first place, right? How am I actually placing those blocks on there? So that's an initial deployment, right? How do I even get the thing up and running? And then how do I upgrade it? How do I perform those lifecycle operations? How do I replace a component? Because yes, you may think in that Lego castle example, you're just replacing some blocks. But sometimes that one block is on top of another block and it's kind of interweaved. And it's not as simple as just pulling one out and putting another one in. And so there are also, I completely agree. These are very valid buckets to think about, but also the initial deployment and ongoing maintenance is top of mind for me in my work.
Yeah, that's right. And I'm just reading through as you were saying that, Rhys. I was just reading through some of the chat. Martin Shin says that the Rich Hickey talk was his favorite talk. I assume his favorite talk so far. Maybe after this webinar,
well, exactly
favorite talk. Lots of comments about Rhys and how cool he is. Wow, that's really got a fan base here.
Too kind.
All right, so in this theme of Legos, I always remember this tweet of Kelsey's from 2017, which was approximately 1,000 years ago, which is Kubernetes is a platform for building platforms. And so if you think in the there's kind of this pendulum that swings, I think, in our industry between the all-in-one platform, the Heroku that does everything and makes it super easy, to the everything is composable and I need to build things out of building blocks. And Kubernetes is definitely on one side of that pendulum, right? And I think this is part of what made Kubernetes so successful, is that it was built for composability, and it was built with a really well-defined boundary that said, here's what we do, and everything outside of this boundary is up to you. And that, not only has spawned the entire ecosystem of CNCF components and and all the projects that we like to play with, but I think that's made that kind of design for Kubernetes has made Kubernetes really successful and popular. And it's avoided, one of the kind of standard ways that software projects go wrong, which is scope increases. I want to do this. I want to do that. I want to do that. So if you're using Kubernetes, the fact of life is whether you like to or not, you have to use a bunch of other components too. And I was going to ask you this hard-hitting question, Rhys, but then I put the answer right on the slide. Well, maybe I'll just ask you anyways. If you close your eyes and you don't look at the slides, how many projects do you think the average organization uses alongside Kubernetes?
So I wouldn't have assumed it was 20. So for the multi-project, that is actually, I work with customers all day long, and I would have assumed, I don't know, 10, but not 20.
Yeah, it's crazy. It's crazy. Now, I put the average here. I didn't put the median. The median is 14, so that's like a little more palatable. But I wanted the big number, so I violated my own rule of statistics, which is average is meaningless and the median is useful. But what I did is I looked at CNCF 2023 survey data, and I filtered out, this is like, there's a lot of responses in there. And I filtered out everyone who was like, I'm just getting started with containers, or my organization is just beginning to use Kubernetes. So I just got responses from people who were using, kind of who were in these mature organizations who had experience with Kubernetes and weren't just getting started. And then the other thing, statistically, if you want to dig into this, is these are responses from individuals. They're not responses from companies. And it's kind of I don't want to say flaw in the CNCF survey, but it's not the case that organizations on average use 20. It's like the responses in the survey of people, many of whom might be working at the same company, used on average 20. Right. So some caveats in here, but still, you're right. That number is really profound. That's like shockingly high. And this is just the CNCF graduated, incubating, and sandbox, and sandbox projects. So if there are projects outside the CNCF, then like those also, get thrown into here on top of that 20. So that was pretty shocking to me.
It is.
Hey, we're given this goal of build a platform, right?
Yeah. I think we have to try and strike a balance, or these organizations have to try and strike a balance between having a flexible yet likely complex with lots of components, and having maybe a little bit more lightweight, stable, and predictable platform. I think that's kind of what it comes down to. Customers are going to have to choose where they want to be. There's always going to be a bit of a compromise.
Yeah, definitely. And Augusto in the chat is saying this is why he likes Harvester. There's a base foundation. And I think we've seen this. We've seen the pendulum start to swing a little bit back, and certainly SUSE and Rancher are providing distributions with components kind of pre-baked in, so that you're not faced with, like, when I see this chart, which is the CNCF landscape, which they do their best to present, this looks like this is like looking out the prison bars. It's like, what are you going to do here? How do you pick 20 from here? How do you navigate this landscape? So the pendulum starts to swing back a little bit, and you need some guidance. You need your concierge to help you pick the right projects here. But the fact that there's so many projects in the ecosystem, I think it's also kind of cool. It means that there's a lot of discovery and a lot of advancement, and some of these projects thrive and some of them don't, and the ones that do, presumably become popular because they're solving a problem. And so it's a nice model in a lot of ways, even if staring at this landscape is kind of horrifying.
Yeah, it's terrifying, but also to me it represents the health of the ecosystem that we work in, right? I think it's great that there's so much choice out there. I always say that the world would be a very boring place. I mean, it would be a very stable place in many ways, but it'd be a very boring place if we were all basically building the same infrastructure. There really is no one size fits all for how you deploy and manage this infrastructure. And so to me, this represents a good thing, even though there's likely some duplication in some areas, but I think freedom of choice is always a good thing.
Yeah, for sure. And, to me, it almost seems like, when you're living in a city, people are either complaining that like, oh, too many people are starting to move in, or they're complaining that, oh, everyone's leaving the city. Of those two, I'd rather be in a city where lots of people are coming because things are growing, things are expanding, right? And so if you think of the ecosystem, you're either in a software ecosystem that's growing or you're in one that's shrinking. And like, much better to be in one that's growing, even if, it adds choices and confusion. Okay, so I think we have a poll going up about this. I'm curious what those answers are. I think looks like it's still running. We've got 17 responses. I'm going to wait another minute or two and we'll see. We were actually asking our audience live how many CNCF projects they use alongside Kubernetes. And the results, Rhys, will shock you.
I'm sure they will.
Okay, so here, this is a situation. We've got to build these platforms. We're tasked with like delivering all these features. And then we're at, we have to build this out of 20 pieces or whatever, 14, 10, whatever it is. And the problem with complexity is that it compounds. And so that's, I think, what makes this so scary. And anyone who's been in software engineering for more than a year has probably been burned by this very fact, is when things are small, when things are early, it's easy to swallow complexity. It's easy to, it's not that painful. And then as things start scaling, that's what burns you. So, it may not be even obvious on day one that you have this complexity until suddenly you're trying to scale it out by a factor of 10, and then it's very obvious. That's what I think makes this so scary. Okay, so is the solution simplicity? Is that all we have to say, Rhys?
I don't think it's as simple as keeping it simple, right? There's a lot of other decisions that have to play their part in all of this. I was going to try and tag on one kind of example to all of this with regards to compounding complexity. Take lifecycle, for example. Let's assume that all of these components on day 1, day 100, whatever, they all integrate well and everything seems to be okay. But the underlying lifecycle and the support from the vendor, maybe the community, if they change over time, it may mean that all of your other components that are building on that one, you're now out of support for that individual component. And that, to me, is one of the biggest challenges that we have to solve or at least think about in that day 500 of how are all these overlapping components lifecycled, how are they supported, who are they supported by? Are we basing our infrastructure on a component that perhaps doesn't have a vendor supporting it? Is it more of a community thing? And there's nothing wrong with community supported components, of course not. But what is their future? And so I think some of these problems do actually compound together, especially when you have these components stacked on top of each other. So I don't always think it's just keep it simple and minimize the number of components, because as you say, a lot of these components and areas on that landscape, they're required in some way, shape, or form. You just have to try and work out what's best for your organization and minimize the risks.
Or, Rhys, or you can just do all the complicated stuff you want and then leave the company and go to another company. And as long as you keep working on greenfield projects, then you're fine.
What could go wrong?
Well, I mean, for you.
Right.
Okay, so the poll is in. I'm not actually sure whether only I see the results or whether everyone sees the results, but I'll summarize them here, which is 50% of the poll is, here we go. We see it live. 50% actually used between 1 and 5 additional CNCF projects alongside Kubernetes. A quarter of the audience used 5 to 10, and 14% used between 10 and 20, and then 9% used 20 or more. This is a live poll. Look at that.
See, this resonates a little bit more for me than the 20 number we had earlier. So this is good. We
need a live computation of the median number here.
Yeah.
Wow, this is entrancing to watch this. All right. Okay. Thank you, everyone, for participating in that poll. That actually is a nice sanity check for us. So let's keep going with this, because I want to get to the point where I'm really asking you some hard questions, which is what we're all waiting for, instead of for William to wax profound about philosophical topics. But the reason, and this is not a Linkerd webinar, and I'm not really going to talk about Linkerd, even though this is my life's work, and all of my heart and soul have gone into this project, and I've done nothing but live, breathe, and smell of Linkerd for a decade now. But the reason why I started going down this path and thinking about anti-complexities, because for Linkerd, we've been talking about simplicity for so long. That's been kind of like this core value for us. We put it in, every time we're talking about Linkerd, we talk about how it's simple. Every time we're making design choices, we talk about, how does this make things simple, and simple in the Rich Hickey sense, because that was the talk that really kind of stuck with us, even in the very early days. And so, here, like even in our graduation announcement, it's like, you can see that message kind of resonates. I don't know why they used pictures of fruits and vegetables here. I guess it's healthy, Linkerd is not just simple, and it's healthy. But the reason why I started going down the path of anti-complexity is because simple hasn't quite felt like it really captures what we're doing. And so the idea that and this is, I'll say this is kind of a rudimentary idea. It's one that has made sense so far, but this is still very much the early days for me, is to take it, what we're trying to accomplish is something a little bit more than simplicity. And obviously this word anti-complexity is drawn from this very popular book about anti-fragility from Nassim Nicholas Taleb. And the model of anti-fragility is something that's beyond resilient. So it's not just able to withstand pressure or stress. It actually gets stronger in the presence of stress. So, there's a couple examples, and the book is really worth reading if you haven't read it. The human muscular system, right? When you're pumping iron, like me, every day, becoming, swole and powerful, just a profoundly impressive physical specimen, you're tearing your muscles, right? And like, that's what induces those muscles to grow. So when you stress that system, it gets stronger. Carbon nanotubes, I know nothing about, but that was one of the examples. Sounds awesome. They get stronger when you add stress. Airlines, restaurants, Silicon Valley. It's really interesting to think about why those are examples in the book, but those are things that, allegedly in the presence of stress will get stronger. So, and that's kind of the idea, right? So it's beyond resilience. So kind of the analogy there is, if an anti-fragile system is something that gets stronger when it's under stress, then an anti-complex system is something that's got to get simpler when you add stuff to it. Okay, well, that sounds insane.
It really does. That when I immediately read it, I think that's just impossible. Right? Like how could this possibly be the case? Right. They have something that starts off simple and anti-complex, but then when I add things to it, isn't the natural behavior for that system to no longer be in that original simplistic anti-complex state?
Yeah. Well, I was hoping you could take it from here.
Oh, wow. Wow.
No. Okay. So, at first I was ready to throw this in the trash bin. And then I remembered this blog post that we had made. Actually, one of our engineers, Alex, pointed this out to me when I was having a discussion with her. So I kind of, I forgot that we had written this blog post many years ago. 2017. This is like back in the, when Kelsey was tweeting about, platforms and Kubernetes and stuff. But we wrote this blog post, which we since deleted, so you can't even find it, called Making Things Faster by Adding More Steps. And this was in a very early version of Linkerd. What we found was that when you added Linkerd to systems, and we could show this empirically, even though Linkerd was adding latency at each hop, right? You get a proxy at each hop, and the proxy has to do work and think, and so you get kind of natural latency. And you've got like, you're going through localhost, to make the network connection to the, there's like kernel, and you're serializing and deserializing HTTP2 and like all this stuff. We actually could reduce the end-to-end latency because Linkerd was doing fancier load balancing, and it was aware of things like slow endpoints or failing endpoints. You could route around them. And so you had this really interesting phenomenon where even though Linkerd was adding kind of a constant latency at every hop, you could actually get lower end-to-end tail latencies, which is what you really care about. And so, super cool result. And we should definitely do more marketing about this, because like we haven't talked about this since 2017. But that same idea, I think, is core to the idea of anti-complexity, which is there are ways where you can add complexity to a distributed system. And even though you're adding kind of an incremental bit at each hop or at each part, you actually can reduce the you can lower the kind of end-to-end complexity. And so this is where things start getting interesting. Observability is one example. When you add a service mesh, and I promise this is not a Linkerd webinar, so this is like the examples that are at hand for me. But there's other software components that work the same way, right? But when you add a service mesh, you've added complexity. Obviously, even with Linkerd, as simple as it is, it's like there's code, there's stuff, but you've increased the overall observability uniformity, or right now every service or every application on your cluster has the same set of metrics. It's measured the same way. They're reported the same way. You have this uniform set of metrics across the entire cluster. And I think there's a good case for saying that's reduced your overall complexity, right? You've added some code stuff, but now the way that you operate this system as a whole has become less complex. You're not requiring or relying on developers to write their own observability. You're not, trying to navigate between different developers reporting different metrics, or reporting them in slightly different ways, or the time windows are not quite aligned. You've added uniformity. So I think this is actually, as soon as I kind of worked through this example with Alex, this actually, I think this holds water. I think this is actually an example of anti-complexity. Yeah. What's your reaction, Rhys, as the critic?
All right, so I went from having the inability to reconcile the whole idea of adding something to a system and making it more simple, to completely agreeing with what you're saying. I think, a service mesh, and I was immediately thinking observability, right? If you have, and especially in my world where we have to deal with thousands or tens of thousands of these systems, adding additional bits and pieces and components that allow you to do aggregation, be that for observability, be it for lifecycle operations, to simplify connectivity, to standardize the way in which I interact with the systems, I can definitely see a world where adding something is going to make the overhead or the burden of managing systems at scale a lot easier and a lot more straightforward. So yeah, I've gone full circle on this. So
all right,
yeah. I'm no longer a critic. You have.
I've convinced you. So you are allowed to stay on.
Thank
okay.
you.
So believe it or not, that was all kind of the preamble. I really want, especially since this is our first time, I really wanted to introduce this idea of anti-complexity. And now kind of the real meat of this is, one of the requirements for a platform is that it is scalable. And I think this is where your expertise is really going to shine. If I think about the way that we talk about our platforms and the ways they have to scale, there's kind of three. There might be more here, but the three kind of obvious ones that came to my mind was, number one, traffic, right? We got to scale, to handle arbitrary amounts of traffic. I cross that out because I don't want to talk about that here. There's so much material out there about pod auto scaling, and there's a lot of. It's not to say it's not a serious topic, but there's a lot of material out there. The other two axes I think are much less talked about, and this is much more interesting from my perspective, which is you have to scale to handle increases in developers, and you have to scale to handle increases in business requirements. So I kind of drew these two axes in a highly sophisticated mathematical graph up here, where on the top, from going left to right, you've got like the original, ENIAC programmers, and like that's, kind of like what a platform used to have to support. It's like two, probably not quite two, but simple. And then on the right, I've got an image of, I think this is a Roblox.
Roblox dev team.
Yeah, which I used because it was freely available. So I don't have any particular, insight into Roblox's system. And then on the axis, going from top to bottom, unfortunately, I have that same graph, that I pulled, or same graphic that I pulled from before. We've got simple features at the top, and kind of more complex features on the bottom. So going from left to right, you can imagine, okay, scaling to support developers. Life is easy when you've got one developer, maybe. It's very different when you've got 1,000 or 10,000 developers. And then on the bottom, you've got, or on the y-axis, you've got the business requirements. So I think this is the part where the theme of this webinar is scalability. This is the part where I think things start getting really interesting. So maybe just as a starting point, Rhys, I can ask you, can you tell us a little bit about your background in terms of like platform building and why you are even relevant to anyone on this webinar?
Well, I'm not sure we're going to answer the question as to whether I'm relevant, but I'll definitely give you an answer to the question. So in terms of my background, so I'm, I guess, roughly 2 decades into my career at this point. My background historically has always been in Linux system management, application deployment, infrastructure deployment. I started life in the defense sector, doing a lot of kind of communication and encrypted communications for the military. And I then moved into, I actually went and worked at Red Hat. I was there for around about 14 years. I did a lot of, rode the wave of virtualization, the onset of cloud computing, for those that can remember the onset of cloud computing. And then I got heavily involved in what was originally OpenShift and then OpenStack. And so, the complexity of those types of systems has always been very important to me, and problems that I've had to deal with lots of different customers across those technologies. Around about 2 years ago, I joined SUSE. Absolutely love being here at SUSE, and I'm now running the Edge engineering team here at SUSE. And so I'm able to try and take some of those lessons learned about how we deploy, how do we scale, how do we secure, how do we manage some of those infrastructures from a cloud native perspective, but do it in scalability in a huge, just an order of magnitude much higher than what I've ever done before. I remember some of the early OpenStack days, we were talking about deploying, hundreds of nodes. Now I have to talk about deploying, tens or hundreds of thousands of nodes. And so for me, that challenge is really, really exciting.
Yeah. So tell us a little bit about that. So Edge, is that an example of scalability? Does that fit into one of these axes, or is that another axis entirely?
I think it's an axis of itself, right? Because all of these buckets, like security, observability, resilience, scalability is there, but just at this order of magnitude, I think creates additional challenges that you perhaps would never have expected to be there when you're talking about traditional infrastructure. Also, there's a lot of overlap, right? So like security and observability is critical, but for us, security, and especially doing at scale, we're putting infrastructure next to the user, the subscriber, or the source of data. There's inherent security challenges and issues with doing so. Historically, if you're putting your application in the public cloud, typically it's the only way of getting into that system is via the network, right? Because that infrastructure, it's in a building, it's guarded, there's people with guns protecting the building. But now we're talking about putting infrastructure into a fast food retailer or into a hospital. security becomes a lot more challenging. And how do I, from a scalability perspective, provide governance, risk, and compliance at that level of scale, making sure that it's enforced, making sure that I can define it as code, have it automated? These are the sorts of challenges that we have to embrace. Doing it for a handful of systems, relatively straightforward. Doing it for tens of thousands, much more difficult.
And it seems like some of these security requirements suddenly are actually unique to Edge, where you could have someone walk into, obviously you've got we've got these untrusted connections between like the Edge deployment in the store, and that's communicating back to the data center, and that's going over the open internet. So we need to secure that down. But then you've got other concerns where, someone could walk into the store and like take the Edge device and run away with it. And now, does that suddenly have data that, is valuable to the business? Are they chopping it up for parts, or are they selling that to, competitors?
Right. Think about a much more extreme example. It's a medical device. What is more important or more critical than your own medical data? So, if there is infrastructure in a healthcare environment and someone literally walks into the hospital, onto the ward, pulls that device away, what guarantees can I give to those medical customers that their systems, their data is protected? The data can't be retrieved. Just having that physical access to the equipment opens up these attack vectors that are very difficult to protect against. And as I said, trying to do that at scale is very, very challenging.
Do you think so? I kind of gave this very rudimentary framework of anti-complexity. Do you think that framework even makes sense, to talk about in the context of scalability and platform scalability in any of these dimensions?
I think it does. Earlier on, you were talking about the fact that, ideally reducing the number of components leads to a more simple system, even though we may not always agree with that. And also that there's no one size fits all, right? Different organizations are going to have different needs for deploying multiple components. But for me, the fewer moving parts that are involved, the lower the risk or the footprint that I have to worry about from a risk perspective. There are fewer components that I have to worry about, as we talked about earlier, a support lifecycle for. How are they, where did the code come from? How is it built? Is it secure? Do I have a FIPS certification, for example? All of these, if I can reduce the number of components that are involved in that stack, then I think it does help from my security posture perspective. It really does. It also, from outside of a security posture perspective, it also helps with some of the other challenges I have to deal with, because Edge to me is more of a management at scale challenge. That is the core thing that we have to solve for. So the fewer moving pieces that are there, it makes the deployment experience easier, makes the lifecycle management experience a little bit more simple from observability, from security. The more simple the infrastructure is, the easier it is to manage and maintain a good security posture from my perspective.
Yeah. Okay, great. So, I have a lot of questions to ask you in terms of what is the advice that you would give to someone who is building a Kubernetes platform. But before we do that, we actually did another poll, and I think the results are ready for us to show.
Sure.
I asked everyone who was attending, of these 5 business requirements, which one was the most important? And that's like an impossible question, because they're all important. But I was curious to see what people would say. 50% picked resilience as the most critical business requirement. That's the thing that's most likely to get you fired, I guess, is the way, it's a way of, really interpreting this. Something else, 4%. Okay, I would, anyone who picked something else, please type it in the chat. I would definitely like to hear what that is. And then, the usual smattering of security, observability, scalability, developer experience. Unfortunately, only 15% picked scalability. So sorry, Rhys, you're only 15% important for this audience. And actually, the next webinar we're doing, which doesn't involve you, is going to focus on resilience. So that one will be probably much better.
No doubt. Well, I won't be on it, so it's guaranteed to be better.
Yeah, but really interesting. So, reliability is still kind of the key scary factor for some of these platforms. And I think that makes sense. Obviously, you've talked about the some of the extreme examples of that in the edge world, but even in good old-fashioned cloud computing, which maybe is not so old-fashioned, reliability is fundamentally, it's an exercise in building reliable systems out of these very unreliable components that you don't even control. So, I think there's lots of opportunity to talk about anti-complexity.
Absolutely. I think it's, you don't want to build a house of cards, right? If you've got lots of different components, regardless whether it's edge or data center or running on top of virtualization, you're putting components together and you want to know, and I guess designing for anti-complexity and simplicity, you're not building the house of cards. You want to have an infrastructure that can survive the loss of a particular component or machine or rack within the data center, of course. And so, yeah, I think it's very relevant for a lot of different industries, for sure.
Yeah. Yeah, for sure. And we've only got a couple of minutes left, so I want to make sure I get to the really interesting question from my perspective, which is obviously you've seen lots of, examples of this in Edge, but even prior to Edge, you've seen a whole set of platforms. You've been in the field with customers. You've seen them work well. You've seen them work poorly, maybe. What is your advice if you are building a Kubernetes platform, and let's just say you're doing it from scratch? I think that's rarely the case these days. Often you have to inherit something. But what's your top 10, top 1 or 2 most important things that you would want someone to know before they embark in this exercise as kind of the platform owner?
Yeah. So I don't know whether I'm going to come up with 10 off the top of my head, but I'll see what I can do. So the first one I'd probably say is, I know we've covered it before, right? It's we have to recognize that there's no one size fits all. I, of course, can't give the perfect platform for everyone because, of course, it will be very boring if we're all doing the same things. But the reality is that everyone will have differing requirements, right? There's a lot of different choices that need to be made that are very business specific, and they need to support different applications. Some are going to be edge, some are going to be different types of infrastructure. So there's really no one size fits all. But I really like the notion of the keep it simple, KISS principle, right? I think it makes sense to think about what are the absolute bare minimum requirements from a component perspective that are required to operate the platform as it is. You've got to, of course, take into consideration how do you actually do the initial deployment, how do you do the life cycle, how do you observe, secure, and how do you do the communication path between applications and across clusters. What is that bare minimum level of infrastructure that you need? And don't try and overcomplicate it. You see that CNCF landscape, there's thousands of fantastic projects. I'm not suggesting not to look into them, but start small. Think about that smaller level, the smallest, lowest common, denominator infrastructure that you can possibly build out. The next one, this is going to be funny coming from a vendor, but unless you have an army of engineers that are going to go maintain the infrastructure, think about consuming core bits of infrastructure from a trusted vendor, right? They've done this before. They understand how it works. I know that won't resonate with everyone, but I think that there's a lot of vendors out there that have really got a lot of experience in that. Leverage that.
Yeah, I think everyone ends up in a build versus buy situation, and it's really just a question of where are you spending your money, and
exactly.
Maybe more important than that, where are you spending your innovation tokens? We didn't really talk about that idea, but
right.
How much of your critical creativity are you devoting to this versus something else that maybe is higher leverage for the business?
Totally agreed. And with that in mind, I like to think about when you're building an infrastructure. Try and draw almost groups or lines of demarcation within your stack. I think it makes a little bit more sense to think of perhaps one particular area, which might be like the base operating system, Kubernetes, and maybe like networking or something like that, as a group that is thought about as a collective. They're deployed and managed together and not really thinking about everything as individual components. Complexity, breaking everything down into individual components, of course, gives you a little bit of flexibility, but it also comes at the cost of maybe predictability and stability when you're grouping some of these things together. And then within those groups or within those layers, pick components that are perhaps in themselves easily detachable, replaceable, have minimal links to other components, or have minimal dependencies in the rest of the stack.
The Lego blocks.
Right, the Lego blocks, but without locking yourself into future design decisions that are very, very difficult to unpick. You really want to think about maximizing your flexibility in the future. So that's just a few that come off the top of my head. As I said, there's no one size fits all, but some simple design principles I think that make sense.
Yeah, no, thank you. That really is helpful, and I think especially for people who are getting started, or even if you're tackling this kind of the second time around, there's so much out there to learn. We are just about at time. I am trying another experiment where, if you're not sick of seeing this hideous face in front of you, I'm actually going to try doing a couple one-on-one meetings with folks. And I'm going to talk a little bit about, obviously anti-complexity, everything that I've learned from Rhys and everything that we've learned from our customers, and try and make that as valuable a conversation to you as possible. I spent the past 10 years neck deep, nose deep in these very murky waters of how do we build platforms on top of Kubernetes, meet the business requirements, meet the requirements of scalability, and how do we do it in a way where we don't end up in hot, murky water. We manage somehow to build a platform. That's an evolving conversation, of course. So click the button if you see the button. I would love to talk to you all one-on-one. And Rhys, I want to say thank you so much for participating in this. I know we threw you right into the deep end, and this is, in some ways, the first time we've ever really talked about some of these ideas. So thank you for sharing your wisdom and your expertise.
Pleasure to be here. Thank you so much for having me.
Thank you, everyone, for attending. We will be doing one of these a month. Please click the button or send me an email. I would love to talk to you, especially if this idea either resonated with you or if you thought it was crazy. Would love to hear from you. And thank you so much, everyone.
Thanks, folks. Have a good day.